Hi friends, today we are going to talk about the different types of numbers. Now, there's many different times that we talk about a group of numbers, or like the integers or the rational numbers. And it helps to know how these all fit together. So I like to talk about numbers kind of in the way that civilization introduced numbers. I feel like that makes it more understandable when we talk about how we got numbers in the first place. So to make it concrete, let's talk about early people. And I like to use Buffalo because I'm a Kansas girl, Buffalo. So when people first started talking about numbers, it was in order to describe what they saw. So they would say, there's 3 buffalo, I can see 5 buffalo, okay? So it was natural that they would use numbers to describe what they saw. That was the first time that we really needed numbers. So that gives us our first classification of numbers, which is the natural numbers. Now I'm going to draw a circle to represent the group of natural numbers. And the natural numbers, we have a special descriptor for it, and it is an N. And in a textbook, it's like a bold N, but I can't write bold, so we just give it an extra bar through the N. And I'm just going to write up a description over here. So natural numbers, this would be numbers like 1, 2, 3, and so on. These are our counting numbers. All right. So the first way we use numbers is to count things that we could see. It's hard to think about numbers being invented, but that's literally what happened because people came along, they could count what they could see, and then they discovered we need a way to describe I don't see anything. They introduced 0. All right, so 0 became in use, and the introduction of 0 gives us another classification of numbers, and it is the whole numbers, W-H-O-L-E numbers, and that is the natural numbers and 0. So we said there are no buffalo, we introduced 0. So I'm going to draw a circle around my natural numbers, but a little bit bigger, and that's going to be my whole numbers. Okay? My whole numbers, and we don't usually use the fancy descriptor letter for that, so I'm not going to put that up here. My whole numbers, this would be 0, 1, 2, 3, and so on. My counting plus 0. All right? So after people introduced the concept of 0, well, then they introduced the concept of lack. We don't have something. We are missing something. And that would be our negative numbers. So we needed a way to describe lack of things. We are missing 3 buffalo. Things are gone. So that brings us to our integers. So the integers, that grouping is around the natural numbers and the whole numbers because all natural numbers and whole numbers are also integers. So I'm going to draw a circle around the whole numbers and label it integers. Integers have a special symbol, and it is Z. And the Z also gets an extra bar. Let me write that up here to the right. So I'm going to draw that Z, and it gets an extra line on the diagonal. Now my Z's also get a bar straight through that diagonal because I'm a math geek and that's how I do it. So this is our integers. So this would be numbers like all the negative numbers up to -3, -2, -1, 0, 1, 2, 3, and so on. So notice I've got dots on both ends indicating we have the negative whole numbers and the positive whole numbers are all in the integers. Now you might want to know, how come it's a Z? That's kind of silly. There's no Z in integers. It's actually from German. It's German word for number. And it has a Z in it, of course. So that's why we use the Z to represent integers. Okay, so we've counted the buffalo. We've expressed that there are no buffalo. We've expressed that we're lacking buffalo. And then the next evolution of numbers is when we became cooperative and we started sharing things. And so that is going to be my left side here. This is going to be my rational numbers. And I want you to see that word ratio in there. That means all my fractions. All right? Now, another word for fraction is quotient, and the rational numbers are represented as a Q with an extra bar in the Q. So let's write that up. My rational numbers are the outside of the integers, outside of the whole numbers, outside of the natural numbers. Q is my rational numbers. And this is all numbers that can be represented as a fraction. Now, it's harder for me to give you a good list here because there's a lot of numbers that can be written as a fraction. But let's talk about some of them. So something like 1/2. Well, that's obviously a fraction. 3 can also be written as a fraction, 3/1. -1.2 can also be written as a fraction. Notice that any decimal that terminates can be written as a fraction. Okay, 0 can be written as a fraction. So these are our rational numbers. All right, so this box we can label pretty easily according to the evolution of numbers. Now we're going to get into the weird ones where we can't. Now, if a number is not rational, its counterpart is the irrational numbers. All right, the irrational numbers are numbers that cannot be written as a fraction. So these are numbers like square root of 2, pi, e. So these are numbers that can't be written as a fraction. These are non-terminating decimals. And also non-repeating decimals. Okay, so these are our irrational numbers, and the main thing is they're not rational numbers. When we put together the rational and the irrational, we get the real numbers. And we write that as a capital R with a bar through it. Let's write that one over here. So my real numbers is the irrational plus the rational. Okay, and the real numbers represent the numbers that we can graph on a Cartesian coordinate system or a traditional XY grid. They can be graphed on that. So they may be ugly numbers, but we can find them and estimate them and put them on a graph. Now, you might wonder, what's in this other box? What else is there in the world that we could talk about in terms of numbers? And that is our complex numbers. also known as our imaginary numbers. And this is abbreviated with a C with a bar through it. These are numbers that look like A plus B times I. And you're going to be dealing with I, or imaginary numbers. The most important thing to remember is that the complex numbers are separate from the real numbers. So occasionally you will get an answer to an equation that is a complex answer, and you might be asked to give that answer in A plus BI form, or you might be asked to say it's not a real number. So it's important to be able to know how these two interact with one another. Let's go ahead and add complex numbers to our list. All right, so now we have a visual of how our number systems interact. And we also can think about how they fit together. So for example, all natural numbers are also rational numbers. All irrational numbers are also real numbers. Natural numbers are also whole numbers. But I can't say that all whole numbers are natural numbers. So we have some subsets here, and it's important to know how they interact. All right, as you are solving problems, solving equations, it helps to know what your solutions look like so you can know what the graph is going to look like.